So in this lesson, we are going to discuss about the area, right? So then circumference, area and circumference of a circle, right? Of a circle, or we are going to discuss about the area of sectors with circles, right? So then with the circular movements, we will take it later. Right. So then if I take a circle, right? So then first we will quickly go through the features of a circle. So then we don't have the straight edge. We just have the circular movement, right? The edge is curvy, not the straight one. And in the middle, we have the center. From center to circumference, this outer boundary we name as the circumference. And from here to here, we have the radius. And here to here, we have again radius. When I add them together, that is 2r. This 2r is equal to diameter. These are the basic things you should know. The center we have, then circular path we name as the circumference. From center to the circumference, if I draw a line, that will be radius. And if I join a point on the circumference here and point on the circumference here across the center that we call the diameter, diameter D is equal to 2 times R. So those are the basic things we should know. And that if you can remember, in grade 6 onwards that we learn how to get the area of a square, how to get the area of the rectangle, triangle, then we talk about the parallelogram, trapezium, that we had different shapes. All these shapes, we had the straight lines. We had the length, width, sometimes it is the base or the perpendicular height. All these measurements we discussed so far with all these shapes put there, those are the straight edges, the straight lines. But here, when we are talking about the circles, we don't have the straight edges. So therefore, for an example, the perimeter, that is the total of the outer boundary lengths. So then we add all the sides together and we get the perimeter, the outer boundary. But if I want to get the perimeter of the circle, here that I don't have any straight edge to add like that, right? If it is a square, we know we add all the 4 sides, rectangle, parallelogram, triangle, any of all these shapes we have discussed so far. We had the straight edges and we add all the straight edges together to get the perimeter. But here I don't have such thing. And mathematicians, what they have done so many investigations and they have found and they have calculated and introduced the formulas for circles. How to find the area of a circle and how to find the circumference of a circle. So what does this mean, the circumference? So that is the perimeter of a circle. The special name we use for that, perimeter of the circle. That means outer boundary of the circle, right? Outer boundary of the circle. The special name is given, that is circumference. And first, I'm going to talk about the area because the circumference part is a little bit confusing when it comes to the perimeter of the sectors. I'm not going to cover that part first. First, we will take the area of the circle because it is easier to understand. Mathematicians, they have done this investigations and they have calculated and they have introduced. If you want to get the area of a circle, how do you find this? 5r squared. Now, r you know now. R is the radius of the circle. What is this 5? It is a mathematical symbol. And later when you move to grade 9 onwards, especially in the Edexcel curriculum, we discuss about this 5 and we talk about whether this is a rational number or irrational number. So then you will be having further discussions about this 5. But for the time being, you keep this in your mind that 5 is a mathematical symbol where we use to calculate the area and circumference of a circle. And again, mathematicians, they have found the value of 5. It is sometimes they use it as 22/7, and sometimes they use it as 3.142, and sometimes we use it as 3.14. So what is the 5 value you want to use? It will be given in the question. You don't want to worry. Either you want that. Here we have confusions that either we are going to do 22/7 or 3.142 or 3.14 or anything else. It's kind of a confusion for you if they have not given it at this stage. But later you know what to do when you move to the grade 9 and onwards, that you know what to do and how to use this. But for the time being, Pute, in the exam paper, they will give you 5 is what? 5 is equal to, consider 5 is equal to 22/7. Or they will give you 5 is equal to 3.142 and 5 is equal to 3.14. So likewise, they will give you the value you want to use, right? Based on that, you can use. So then the 5r squared, that if I expand this, what does this mean? 5 times r times r. So that is how to substitute the values, that if they have mentioned that 5 is equal to 22/7, we just write 22/7 times whatever the r value they have given times whatever the r value they have given. And based on that, we calculate the area. And always the unit can be millimeter squared, or it can be centimeter squared, it can be meter squared, like any other shape. So when you are calculating the area, units will be like that based on the radius units. If they have measured the radius in millimeters, your area value will be millimeter square. If they have measured the radius in centimeters, your area units will be centimeter squared. Likewise, that according to the units of the radius, the units of the area will be varying. Now, so this is how we get the area of a full circle. Let's say we don't have the full circle. Instead, we have the half circle. We have a half circle. We call this a semicircle, right? Here, this is the center, and I have cut the half of the circle. Now I have only one half. So then this is the radius, right? And how I'm going to get the area of this? So then full circle, it is 5r squared. Full circle, it is 5r squared. And I have only half of it. Therefore, I divide by 2, right? So then sometimes when you are doing the calculation, you can write it like this, 5r squared divide by 2, right? So then later when you are doing the sums, you will realize why I wrote it like this, 5r squared divided by 2. So this is how we write it, right? So then the same way, let's say I don't have half. Instead, I have, let's say, quarter, right? I have quarter, right? I have quarter. And here, this is the radius value. And this is a quarter of a circle, right? This is a quarter of a circle. Then how I'm going to get that? I know the full circle, it is 5r squared. But here I don't have full circle. Instead, I have only the quarter of that. Therefore, I want to divide this by 4. If need, you can write it like this, 5r squared divide by 4, right? So these are the main 3 equations. A full circle area, it is 5r squared. And then the phi value can be either 22/7, 3.142, 3.14. And then we want to understand what is the unit of the area. It can be millimeter square, centimeter square, meter square. And then we have, sorry, the half circle or the semicircle, 5r squared divided by 2. If it is a quarter circle, 5r squared divided by 4. Right? So then these are very simple. Now I'm moving to the complex part of this. Let's say that I don't have the full circle, I don't have the semicircle or the quarter circle. Instead, I have only the portion of the circle, right? So then the sector of the circle will say. So then I have the full circle here. You just imagine that you have the full circle and you have that kind of this small portion. Let's say this is a land and I want to find the area of this land. and this is the center, and this is the radius, right? This is the radius, and this is also the radius value, okay? And this angle can be anything. I write the theta. This is how I write the theta, Pute. You write it like this, and this is a Greek letter. Don't worry about that theta. This can be anything. It can be 30 degrees, 45 degrees, 60 degrees, 90 degrees. It can be anything, right? It can be anything. And that this theta value. Now you just imagine the full circle area, right? The full circle area, it was 5r square. What do you mean by the full circle, children? It covers 360 degrees, right? The full circle, it covers 360 degrees. So then 360 degree area is equal to 5r square. Why I brought it like that? Because here in this sector, we have the theta degree value, Nipute. So then to deal with this theta degree, I want to bring the equation in terms of the degree value, that I want to convert this into angular form. For that, I convert the full circle into degrees. The full circle means 360 degrees. That is equal to 5r squared. So then the 1 degree is equal to 5r squared divided by 360. Here I don't have 360 degree, or I don't have 1 degree. Instead, I have theta degree. So then how I'm going to find it? 5r squared divided by 360 multiplied by theta, right? So that I don't want to use the degree sign here, and this degree sign and this degree sign will be cancelled off, but you can keep it like this. So then you write the equation, area of any sector, area of a sector, we call this small portion the sector. You get that you want to find the angle related to that sector, that is the theta value. You first check the 5r squared value and divide it by 360 degrees and multiply whatever the theta degree value they have given in the sector. That can be anything. It can be 105, it can be 90, it can be 270, it can be anything. See what you can see, the angle value inside the sector, not the outside part, inside the sector, what you see. So these are the 4 equations you want to keep in your mind. 5r squared, 5r squared divided by 2, 5r squared divided by 4, and 5r squared divided by 360 into theta degree. So this is all about the area, okay? Now I'm moving to the circumference. So then circumference, the full circle, circumference C value, mathematicians, they have introduced the formula 2, 5r. What do you mean by 2, 5r? 2 times 5 times r. And I take this r closer to 2, 2 times r times 5. And we know 2 times r. Earlier, I told you that the 2r values is equal to the d value. 2 times r is equal to d value. Therefore, here I write instead of 2r, d. So then I have d times 5. So then we introduce 2 formula to the circumference, right? Circumference, we have 2 formulas. Circumference, the C value. We have 2 formulas. One is 25R, other one is 5D. Now, when you have 2 such equations and you are doing the sums, now you might think that which equation I should find. So you can use either equation, that's totally fine, you get the same answer, but you want to use the equation based on the available information. If you have radius value in the question, you can use 2, 5. If you have the diameter, that you can use the 5d value.